Hi students, am I audible? Am I audible? Good evening everyone. Welcome to Goscore Learning, the fastest growing ethic industry in Middle East. I'm your Dhanya ma'am. Today I'm here with the second chapter, that is Electrochemistry of Grade 12 Chemistry. Okay, so are you all ready? Can we start the session? Okay, today we are going to discuss about the electrochemistry. So we know that in our day-to-day life, we are dealing with a lot of electronic equipments, is right? So we cannot imagine a day without our mobile or any electrical equipments, is right? So there is a very important role of electrochemistry in our day-to-day life. So today we are going to discuss in detail about the what is this electrochemistry and what are the different types of cells and a detailed description of some batteries, corrosions, everything is included in this chapter. And in today's session, we will be discussing about the electrochemical cell and the representation of electrochemical cell. Okay, just before that, we can see what is actually mean by electrochemistry. Okay, so electrochemistry is a branch of the chemistry that deals with the relationship between the chemical energy and electrical energy and the interconversion of these two forms of energy. So in electrochemistry, we will be dealing or we will be discussing about the electrical energy as well as the chemical energy and the interconversion of this electrical and chemical energy. So this electrochemistry, we can categorize it into two types, electrolytic conductance and electrochemical cells. Electrolytic conductance is very easy portion. Okay, so that we can discuss it in the next part. And in today's session, we will be discussing the second part, that is the electrochemical cell. Okay, so what is actually mean by this electrochemical cell? Electrochemical cells are the devices that convert the chemical energy into electrical energy or electrical energy to chemical energy. That is what included in the electrochemical cell. So, electrochemical cells are the devices that will convert the chemical energy to electrical energy or electrical energy to chemical energy. So, in electrochemical cells, we have to discuss about this both interconversions. Okay. So, are you all ready to learn about electrochemical cells? Can we start it? Okay. So, first we can, as I told you, the electrochemical cells, there will be conversion of electrical energy to chemical energy as well as from chemical energy to electrical energy. So, based on this conversion, there are two types of cells. Okay, we can categorize the electrochemical cells into two categories. The first one is electrolytic cell and the second one is galvanic cell or is also called as voltaic cell. Okay. So, what is the difference between this electrolytic cell and the galvanic cell? We have told that, we already described that in the electrochemical cells, there is conversion of electrical energy to chemical energy as well as chemical energy to electrical energy. So, one among this electrolytic cell and galvanic cell, the one will be having this electrical to chemical energy conversion, the one will be having the chemical to electrical conversion, right? So, now let's see what is the difference between these two cells. Okay, so before that, I can give you one example that we all are using the mobile phones, right? So, our mobile phone actually have this both cells, the electrolytic cell as well as the galvanic cell, right? Whenever the battery is low, what we will do? We will put it in an electric plug so that the electrical energy is getting from the electrical socket, right? There, when we are charging the mobile phone, their electrical energy is converting to chemical energy, right? And once our battery is full, we will just discharge it. And after that, whenever we are just switching on, we will get the flashlight and we can use it, right? There is no need of plugging into an electrical source for using that time, right? So there, while we are using that one, while we are using the mobile phones, at that time, there, the chemical energy is converting to electrical energy, right? I hope it is clear. When we are charging the mobile phone, the electrical energy is converting to chemical energy. And once our battery is full and we disconnected it, and whenever we are using it outside or whenever we are using it, we are converting the chemical energy to electrical energy. Okay, let's see. Here, the electrolytic cells. In electrolytic cells, actually, the conversion, in electrolytic cells, the process are non-spontaneous process. Okay, in electrolytic cells, the processes are non-spontaneous in nature. Okay, and we have learned in the 11th standard that for all the non-spontaneous process, actually what is meant by this non-spontaneous? Non-spontaneous means there is no need of giving an external push. Okay, there is no need of giving the external push for starting the reaction, right? Okay, so okay. So non-spontaneous reactions, and we learned that for non-spontaneous reactions, the delta G, what is the delta G? Delta G is Gibbs free energy, right? And we have already learned in the 11th standard that for non-spontaneous process, the delta G value is always positive value, right? Okay. Okay. So non-spontaneous reactions means they are not spontaneous. I think I have told it in a wrong way. Non-spontaneous process means they are not spontaneous, right? We have to give an external push to start the reaction. Okay, so it is not spontaneous. Okay, so somebody has to push it to start, right? That is what mean by the non-spontaneous reactions. And for all the non-spontaneous reaction, the Gibbs free energy, that is delta G value, should be always positive value. And this is the cell that our mobile will act when we are charging it. Okay, it's not spontaneously doing. We have to put it in the electric socket, right, to get it converted or to get it charged, isn't it? So here in the electrolytic cell, it is a non-spontaneous process and the delta G value is positive value. Here, what the conversion is occurring? We are putting into the electrical socket and the phone is getting charged, right? So at that time, electrical energy is converting into chemical energy. So in an electrolytic cell, when we are charging the mobile phone, our phone will act as an electrolytic cell. That means the electrical energy is converting into chemical energy. So in an electrolytic cell, the electric energy is converting to what? Chemical energy, right? Okay. So I hope the electrolytic cell is clear for you, right? So in an electrolytic cell, these processes are non-spontaneous. That means we have to give a starting or we have to push up. Once we put it in the electrical circuit, then only it will start charging, right? It's not spontaneous process, right? So it's a non-spontaneous process. By comparing with the mobile phone itself, you can clearly identify what is happening in the electrolytic cell, right? So in an electrolytic cell, it is non-spontaneous, and for all the non-spontaneous process, the Gibbs free energy change, the change in the Gibbs energy, that is delta G value, will be positive value, right? And there, what is the conversion occurring? The electrical energy is changing into chemical energy. Okay, so that is the main point that you should know about the electrolytic cell. Okay, now your phone is fully charged, right? And once you remove discharge from the electric socket, whenever you are opening it, you can use it, right? No need of further giving the electrical charge to open it, right? Once until the battery is full. Okay, so in the galvanic cell, it is spontaneous, no need of external push, it will work by its own. So this is galvanic cells are spontaneous process, and we already know that for spontaneous process the delta G value should be negative for spontaneous process. So here the Gibbs free energy delta G value should be negative, right? So here what the conversion is taking place, whatever the energy released during the chemical process is converting into electrical energy. That's why we can use it, right? So here in the galvanic cell, the chemical energy is converting to what? Electrical energy, right? So these are the main difference between the electrolytic cell and the galvanic cell. So for an electrolytic cell, the process is non-spontaneous and the delta G value should be negative. Delta G value is positive. Sorry, the delta G value is positive, and there the electrical energy to chemical energy conversion is occurring. And for the galvanic cell, the process is spontaneous and the delta G is negative, and chemical energy to electrical energy conversion is taking place. Okay, and the one more very important thing is, for all the spontaneous process, for all the spontaneous reactions, the delta G value should be negative, and for all the non-spontaneous reactions, the delta G value should be positive, right? Okay. And whenever a reactant is changing into product, what is actually the chemical energy associated with this reaction? Is it delta H? No. The delta H is enthalpy. It is not the chemical energy, it is the enthalpy change associated with the reaction, right? So what will be the chemical energy? This chemical energy is given by the delta G. Okay, so for a chemical reaction, the chemical energy is given by the delta G value. Okay, so now let's see in detail about the electrolytic cell. Okay, in an electrolytic cell, what are the points that we know now? In electrolytic cells, what are the things we discussed now? In electrolytic cells, they are non-spontaneous, right? Non-spontaneous, and the delta G value is positive, and there the conversion of electrical energy to chemical energy, right? There the conversion of electrical energy to chemical energy. Up till this, these all things we already know about the electrolytic cell, right? Now see, here I have taken the sodium chloride. Sodium chloride is an electrolyte. What is electrolyte? Electrolyte is an aqueous solution or a molten solution which can conduct electricity. The solution which can conduct electricity in its aqueous form or in the molten state is what we call the electrolyte. Okay. So why it can conduct electricity? For a solution to conduct electricity, it should need free ions. Okay. For an aqueous solution, if it has to conduct electricity, it should contain free ions in it, right? So We have taken the sodium chloride as the electrolyte, and when in the aqueous solution, we know that the sodium chloride will be converting into Na plus and the Cl minus ions, right? So, since there are free ions present, it can conduct electricity. And for a metal surface to conduct electricity, what it needed? For a metal surface to conduct electricity, it should require free electrons in it. Okay, got the difference? For a solid substance to conduct electricity, it should contain free electrons in it. And for an aqueous solution to conduct electricity, or a molten substance to conduct electricity, it should contain free ions in it. Okay. So, here we have taken the sodium chloride. In the aqueous solution, the sodium chloride will form Na plus and Cl minus ions, right? So, there will be Na plus Cl minus ions in it. Okay. And here I have kept two metal rods. Okay. Two metal rods, and those metal rods are called electrodes. Okay. These metal rods are called electrodes, and these two metal electrodes are dipped in the electrolyte solution, right? And in the electrolytic cell, the electrical energy is converted to chemical energy, right? So we have to provide the external electric circuit, right? For that, I have connected these two metal electrodes to the terminals of a battery. Okay, and this is the positive terminal of the battery, and this is the negative terminal of the battery. And the electrode, this electrode is connected to the positive terminal of the battery, right? And the electrode which is connected to the positive terminal of the battery is called the anode. Okay, the anode is the metal rod that is connected to the positive terminal of the battery, and the metal rod or the electrode which is connected to the negative terminal is called a cathode. Okay, so this is the diagrammatic representation of an electrolytic cell. Now let's see in an electrolytic cell what actually happens. So we know that here in the aqueous solution of sodium chloride, Na plus and Cl minus ions are there, right? And this anode is connected to the positive terminal and cathode is connected to the negative terminal of the battery. So this Na plus ions will always have the tendency to move towards the cathode because they are Na plus are positive charge and cathode is negative charged electrode, right? So opposite charges will have an attraction, and this Na plus ions will always have the tendency to move towards the cathode. And same way, the Cl minus ions have the tendency to move towards the anode, right? Because Cl minus are negatively charged and the anode is positively charged. The opposite charges have attraction, right? So the Cl minus will move toward the anode and Na plus will move towards the cathode. Okay, so I can write at cathode, at cathode, which is moving sodium, right? This Na plus ions, this Na plus ions will be changing. This Na plus ions will be accepting one electron and getting converted into Na. Okay. And in the cathode, sorry, at anode, the Cl minus means they have excess of electron. The Cl minus will be converting into chlorine gas by losing one electron. This Na plus ion will accept. Na plus mean it has a deficiency of electron, right? This Na plus will accept one electron and getting converted into solid Na sodium and a solid sodium, and at the anode the Cl minus ion. Cl minus mean it has the electron excess electron in it and it will be losing one electron to form the chlorine gas, right? So see what is actually happening at anode. anode, there is the loss of electron, right? So what is actually the loss of electron? We have learned in the redox reaction chapter in the grade 12 that the oxidation process is the loss of electron, right? So here at anode, what is taking place? At anode, the loss of electron is occurring. That means there loss of electrons, that is they are undergoing oxidation, right? Here the one electron is losing from the Cl minus ion and it is getting converted into chlorine, right? So there is loss of electron and loss of electron is nothing but oxidation, right? And what about the cathode? At cathode, the Na plus ion is gaining or accepting electron. The gaining of electron is, the gain of electron is reduction, right? So there the gain of electron occur. That means at cathode reduction occur, right? So this is a very important point that at anode always there oxidation reaction occur and there will be oxidation means there is the loss of electrons, right? And at cathode there will be gaining or accepting of electrons and Na plus is accepting one electron and changes to sodium. So there is reduction process occurring, right? So here this anode is connected to the positive and cathode is connected to the negative. And at anode, the loss of electron is taking place. Loss of electron means there will be deficiency of electron. So it has a positive charge. At cathode, there is gaining of electrons. So there will be more electron cloud here. That means the cathode have a negative charge, right? So that is about the electrolytic cell. Now let's see in an electrolytic cell, the electrode where oxidation happens is known as, so what we learned, where the oxidation taking place is known as, the electrode where oxidation occurring is called the anode, right? So see, about the electrolytic cell, the electrode where the oxidation happens is known as the anode and the electrode where reduction happens is known as the cathode. Okay, we have already discussed it in detail, right? And I told you that we will be taking the metallic plates as the electrodes. The electrodes are nothing but the metallic plates. And here we have mentioned that whenever this Na plus is converting, Na plus is accepting electron and changing to sodium, the Cl minus is giving, losing the electron. So where these free electrons will occur? Will it occur on the aqueous solution or in the electrolyte? No. Okay. These free electrons will not go into the aqueous solution or the electrolyte. These free electrons will always be there on the surface of the metal electrode. Okay, the free electrons will always be there on the surface of the electrodes, the metal rods that we are using. Okay, that's our final point. The free electrons cannot remain in the solution. They are present only on the surface of the electrodes. Okay, so we know that at anode and cathode there will be losing and gaining of electrons, and all those electrons, these free electrons is not entering into the electrolytic solution. They will always present on the surface of the metal electrode. Okay, so that's about the electrolytic cell. I hope electrolytic cell is clear for you. Now we are going to discuss in detail about the galvanic cell. So about the galvanic cell, what are the points we know? We have already discussed about the galvanic cells and we know that in galvanic cell, the process is spontaneous, right? The process is spontaneous and for a spontaneous process, the delta G value is negative. And we know that in galvanic cell, what is the conversion taking place? The chemical energy is converting to electrical energy, right? So there is conversion of chemical energy to electrical energy. Okay. So now see, we already know these 3 points. Okay. Now see, by these points we can write the definition or we can write the explanation for the galvanic cell. So in a galvanic cell is an electrochemical cell that convert the chemical energy of a redox reaction or a chemical energy of a spontaneous reaction into which energy? Electrical energy. So here the chemical energy of the redox reaction, the chemical energy of the spontaneous redox reaction is converting into electrical energy, right? So here the energy is losing, the energy is converting. Okay. So in this device, the Gibbs energy, that is the delta G value, is converted into electrical work. So the delta G is, energy is losing there. So delta G will be negative value, right? So the galvanic cell is an electrochemical cell that converts the chemical energy of a spontaneous redox reaction into electrical energy, and in this device the Gibbs energy of the spontaneous redox reaction is converted into electrical work. Okay, so if you are clear with those 3 points, you can easily define the galvanic cell. Okay, now let's see the diagrammatic representation of a galvanic cell. Okay, okay. So this is what the diagrammatic representation of a galvanic cell. See, in the electrolytic cell, there is only one beaker containing an electrolyte. In that beaker itself, we are putting the two electrodes, the anode and the cathode. But in a galvanic cell, there are two beakers with two different electrolytes. Here in the first beaker, we have taken the zinc sulfate, and in the second beaker, we have taken the copper sulfate, right? So here, we have in the galvanic cell, not like electrolytic cell, we have taken the two separate vessels containing different electrolytes in it, right? And see, here we have taken the zinc sulfate in the first beaker and copper sulfate in the second beaker. And to the beaker containing the zinc sulfate, we are dipping the electrode made up of which metal? The same metal in which the salt solution is present, right? So here we are putting the zinc electrode in this zinc sulfate solution. Okay. Same way here in the copper sulfate solution, which one will be we are putting? We are keeping the electrode, that is copper. Okay. The copper metal rod is kept as the electrode in the copper sulfate solution. Okay. Okay. Now see, here in a galvanic cell, what actually happens is the zinc will be converting into Zn2 plus by losing 2 electrons, right? So here zinc is losing 2 electrons and is converting into 2 Zn2 plus ions. Okay. So, and also the copper Cu2 plus ions is getting converted into copper by gaining, this Cu2 plus ion by gaining 2 electrons, it is converted into copper. Okay, so where the zinc is there, this is the zinc, right? So zinc is in the solid form. The Zn will be losing, the zinc from here will be losing the 2 electrons and is converting into Zn2 plus. It will be converting into Zn2 plus and enter into the zinc sulfate solution, right? So in the zinc sulfate solution there already it will be Zn2 plus and SO4 minus 2 minus ions will be there. And the zinc in from the metal electrode is converting into Zn2 plus by losing 2 electrons, right? So here, see here for the zinc anode, zinc electrode, what is taking place? They are losing the electron, right? So losing electron means Losing electrons means there what is taking place? Losing of electron is oxidation, right? So at which electrode the oxidation will occur? Oxidation always occur at the anode, right? So here the zinc electrode will act as the anode. Okay. So the zinc is converting into Zn2 plus by losing 2 electrons, right? So thus electrons will be there on this metal rod, right? So it is the zinc is converting into Zn2 plus. The zinc is converting into Zn2 plus and the 2 electrons are free there, right? So where these electrons, I told you, these free electrons will not go into the solution. They will be there on the surface of the metal electrode, right? So these 2 electrons will be there on the metal electrode. So at zinc electrode there the oxidation occur and it act as the anode and there will be a cloud of electron on the metal rod. That's why this here the anode is getting a negative charge. Why? Because there is a cloud of electron on the anode metal rod. That's why it's getting a negative charge in it, right? Okay, now see, so don't get confused with the charge on the anode. In the electrolytic cell, we learned that anode is positive charge. But in a galvanic cell, at anode, the oxidation is taking place. That is the losing of electron. And this lost electron will be there on the surface of the metal. And there, what happens? And there, this electron cloud will create a negative charge. And the anode is getting a negative charge there. Okay. So, and what happens in the cathode? See here, this copper Cu2 plus ion is gaining 2 electron and converting into copper. The Cu2 plus ions are present in the aqueous solution and it is converting into copper solid. So, the CuSO4, it will be Cu2 plus and SO4 2 minus ions will be there. This Cu2 plus ions will be gaining 2 electron and deposited on the electrode as Cu. Okay, as copper. So here gain of electron is taking place, right? Gain of electrons. What is gain of electrons? The gain of electrons is reduction, isn't it? So here the gain of electron occur, that is reduction process is taking place. So you can clearly see in the figure that at the cathode the reduction process is occurring. So here what is happening, the Cu2 plus is gaining electrons. So there will be decrease, there will be loss of electron from there and it will be having a positive charge for the cathode. So here there is a cloud of electron and here there is a deficiency of electron. So where the electrons, for what will be the flow of electron? The electron will flow from the anode to the cathode. That is what the flow of electron. The electrons will flow from the anode to the cathode side, right? And you have learned in the physics that if the electron flow is from anode to cathode, what will be the flow of electric current? It will be from cathode to anode, right? So that is the galvanic cell. And see, what is this? There is one more thing in the galvanic cell, that is the salt bridge. Now see here, I will tell you why we have put the salt bridge there. See, here we have to mention that from the zinc rod, the zinc ion is entering into the solution, right? So initially there will be zinc and a sulfate ion concentration same. And as the reaction proceeds, what happens? More Zn2 plus ions are getting into the solution, right? So at the end of the reaction, the Zn2 plus ions concentration will be comparatively greater than SO4 at the ZnSO4 solution, right? And what about the CuSO4? From CuSO4, the Cu2 plus ion is getting deposited as the copper, right? So there will be a decrease in the Cu2 plus ion. So in the copper sulfate solution, the Cu2 plus ions concentration will be very less compared to the SO4 2 minus, isn't it? It's clear from this, right? Okay. So there will be a stoppage of the reaction, right? So In order to maintain the neutrality, we will be keeping this salt bridge. Okay. Usually the salt bridge is made up of inert electrodes. What is inert electrodes? Inert electrodes means that these electrodes will not react with the ions present in the electrolyte. Okay. So, and it is made up of KClO, KNO3 like materials, and it is inert electrodes, and the salt bridge is used to maintain the electrical neutrality. That means as the reaction proceeds, there will be increase in the concentration of Zn2 plus ions in the zinc sulfate solution, zinc sulfate electrolyte, and there is a decrease in the Cu2 plus ions in the cathode side. That is the copper sulfate electrolyte, right? So now see I think this is clear. What is the losing of electron, oxidation, why the anode is getting the negative charge, and what will be the flow of the electron, and what will be the flow of the current. It's all clear for you, right? Now see what is the salt bridge. Here in the galvanic cell, I told you there is a salt bridge is kept in between these two solutions, two beakers, right? Now let's see what is this salt bridge. So the salt bridge, it maintains the electroneutrality. As I told you, the salt bridge is used to maintain the electroneutrality, right? And to complete the circuit, electrical circuit, by allowing the ions to flow from one solution to the other without mixing the two solutions. The salt bridge allows the movement of these ions from one solution to another without mixing the two solutions. And it also helps to reduce the liquid-liquid junction potential. Okay, so these are the main roles of the salt bridge in the galvanic cell. Now, let's see, we have already discussed about the galvanic cell and the electrolytic cell. And in an electrolytic cell, we know that in an electrolytic cell, clearly we know that what the anode is positive and cathode is negative. Whereas in a galvanic cell, the anode is negative and cathode is positive. Right? Okay. So now we can solve some. Okay, before that, before going into some questions, we can see the main difference between the galvanic cell and the electrolytic cell. Okay, we already discussed all these things and these points are crystal clear for you all. Okay, see, in a galvanic cell, we know that it's a device that converts the chemical energy into electrical energy. Okay, we know it, and galvanic cells are spontaneous reactions. The electrical energy is produced as the result of spontaneous redox reactions. In galvanic cells, the electrical energy is produced as a result of the spontaneous chemical reactions. And for spontaneous reactions, the delta G value, the Gibbs free energy value, the delta G is negative here, right? And what is electrolytic cell? In electrolytic cell, it is non-spontaneous. The delta G is positive, and where electrical energy is converting into chemical energy. So, electrolytic cell is the device to convert the electrical energy into chemical energy, and this electrical energy is supplied to the electrolytic solution to bring about the redox reaction. So, here energy is giving. So, the delta G is positive there. So, the free energy change is positive in electrolytic cell, right? Okay, now see the next reaction, next difference. That is, we know that the galvanic cell is based on the redox reaction, which is spontaneous in nature, whereas the electrolytic cell is the redox reaction, which is non-spontaneous in nature, and the reaction will take place only if you supply the electrical energy, right? It is non-spontaneous. We have to give some extra pushing to start the reaction, right? Okay. So, and from the figure diagrammatic representation, it is clearly seen that in an electrolytic cell, we are keeping the solution, electrode, everything in a single beaker, the same beaker, right? So, for an electrolytic cell, both the electrodes are suspended in a solution of or an electrolyte in a single beaker or in the same beaker itself, right? But in the galvanic cell, we usually keep the two electrodes at the separate beakers. The anode and the cathodes are kept in the separate beakers, right? And we are taking it in a separate beaker, we will take the different electrolyte there, right? In galvanic cell, we are taking two different electrolytes, right? Whereas in the electrolytic cell, both the electrodes are immersed in the same electrolyte. So, there will be only one electrolyte in the electrolytic cell. Okay. So, the last one and the very important difference is that we know that in electrolytic cell, the anode is the positive terminal and cathode is the negative pole, right? Whereas in the galvanic cell, the electrode on which oxidation takes place is called the anode and is the negative pole, and the electrode on which reduction takes place is called the cathode and is the positive pole of the galvanic cell. Whereas in the electrolytic cell, the electrode which is connected to the positive terminal of the battery is the anode, and the electrode which is connected to the negative terminal of the battery is the cathode. Okay. So, that is the major difference between the galvanic cell and electrolytic cell. Okay, I hope it is clear for you. Now, let's see some problems. What problems? Some questions. This is based on this portion. Okay. So, a cell reaction would be spontaneous. Delta G value, I have told you it many times in the session that for spontaneous reactions, the delta G value is, for spontaneous process, the delta G value is negative. And for non-spontaneous process, the delta G value is positive, right? So, for the question, the cell reaction would be spontaneous if the delta G value of the reaction is negative. Okay. Now, see, the molten sodium chloride conducts electricity due to the presence of free electrons, free ions, free molecules and atoms of sodium and chlorine. I told you clearly that for an aqueous solution or a molten solution to conduct electricity, what it needed? It required free ions in it, right? And for the solid substances or for the metal rods or any surfaces to conduct electricity, it has to contain free electrons, right? So, since molten sodium chloride, there will be Na plus ions and the Cl minus ions, and this free ions are responsible for conduction of electricity, right? Now, see, which of the following statement is correct? A cathode has negative terminal in both galvanic and electrolytic cell. Anode is positive terminal in both galvanic and electrolytic cell. Cathode and anode are negative terminal in electrolytic and galvanic cell. Cathode and anode are positive terminal in electrolytic and galvanic cell. No need of further explanation. I will show you one thing. See, cathode and anode, the galvanic and electrolytic cell. What will be your option? See, the cathode and anode are negative terminals in electrolytic cell and galvanic cell, right? So, which one will be your option? Here it is cathode and anode are positive terminal. It is wrong. This is wrong. This is wrong. And this will be the option C will be your correct answer. Let's see for the next question. Which of the following statement is correct about galvanic cell? What's actually happening in galvanic cell? Galvanic cell, it is a spontaneous reaction where chemical energy is converting into electrical energy. So, the first option is it converts the chemical energy to electrical energy. That's the right one, right? Second option is electrical energy to chemical energy. It is electrolytic cell. It converts metal from its free state to combined state. That is also wrong. It converts the electrolyte into individual ions. That is also wrong. So, your option is The first option, it converts the chemical energy to electrical energy, right? Okay. So, now we can see how we can represent a cell. Okay, representation of cell, that is cell notation. Okay, so in order to represent the cell, just take the example of galvanic cell. Okay, so in the galvanic cell, what we learned in the losing of electron, that is the oxidation occur at the anode, and where at anode, what is taking place? At anode, the oxidation occur, and there the zinc is converting into oxidation, means loss of electron. Zinc loses 2 electrons and it is converting into Zn2 plus, right? And at cathode, at cathode, what occurs? The reduction takes place, and at cathode, what happens? The Cu2 plus, reduction means gaining of electron. The Cu2 plus accept 2 electron and converted to copper, right? Okay. See, here, how can I represent this galvanic cell? So, in galvanic cell, we know that there is a salt bridge, right? So, for representing the salt bridge, we will be putting a double line, okay? And on the left side of this double line, that is the salt bridge, we will be writing the anode, okay? And on the right side, we will be representing the cathode, right? And while writing the anode, first you have to write the ions. Then you have to, the single line represent the phase transition from ions to gas, then the solid state. Okay. And if the state of the solution, physical state is mentioned, you have to give an ions if it is in aqueous solution, gas, G, solid, S, like this you have to represent. And if the concentration is given in the concentration of electrolyte given, if it is 1 molar, we have to represent. If it is 0.1 molar, you have to represent it with 0.1 molar. Okay, like this we will represent the anode on the left hand side of the salt bridge representation, and on the right hand side the same way we will represent the cathode. That means the ions first, followed by gas, then followed by the solid. Okay, see the cell notation. The electrodes are to be placed at the extreme corners. The electrodes, the metallic electrodes that is in the solid state should be represented on the extreme corners of the notation. And the LHS, the left hand side, represents the anode where oxidation takes place, and the right hand side represents the cathode where the reduction takes place. And there are two half cells are usually separated. These two half cells is that where the oxidation takes place, that is the first half cell, where the reduction takes place, that is the reduction half cell, and this oxidation half cell and the reduction half cell are separated by a double line that represents the salt bridge, right? So this is the cell notation. Now tell me how we can write the cell notation for the galvanic cell. Here in the galvanic cell, first we will write the salt bridge. Okay. On the left side, you should mention the anode. So in the anode, what is the ion? First we will write the ion, that is Zn2 plus ions in the aqueous solution. Okay. Then we will put the phase transition. Is there any gas? No, right? So there is no gas. Then the solid is zinc, Zns. Okay. If this molarity or the concentration is given, you have to mention here whatever the given concentration. I am taking here 1 molar, so I have to write it here. Okay. And on the right hand side, we have to mention the cathode, right? So same way for the cathode also, it will be Cu2 plus, Cu2 plus ions in the aqueous form plus copper solid, right? So this is what the cell notation or the representation of the galvanic cell, right? It's very easy, right? We have to write the electrodes on the extreme corner. The only thing is the anode should be right on the left hand side, the cathode should be right on the right hand side, and these half cells, the oxidation half cell and the reduction half cell, should be separated with a double line that indicate the salt bridge, right? Okay. So the metal and metal ion half cell. Okay, see here I have taken the, I'll draw it. See here we have the we can take the zinc sulfate solution. Okay, this is the ZnSO4 solution. Okay, to that ZnSO4 solution, I am placing the zinc electrode. Okay, this zinc electrode can act as the both as anode as well as cathode. Okay, it depends on how we are using it. See, we can take two cases. For the first case, I am taking the zinc as the anode. Anode means there what happens? Oxidation will occur, right? Oxidation means loss of electrons. So zinc will be converting into Zn2 plus plus 2 electron, right? So here in the first case, if you are taking the zinc as the anode, there Zn2 plus ions will be forming and the zinc act as an anode. In the case 2, I'm taking the zinc as cathode. Cathode means there which one occur? There reduction process will takes place, right? Here the oxidation process. So reduction means gaining of electrons there. The Zn2 plus ion will be gaining 2 electron and converting into zinc, solid zinc, right? So the metal or metal ion half cell, we can either use it as the cathode or as anode, and it depends on how we are using it, how we are connecting it. That depends on the which one it has to be. It would be anode or it has to be cathode. Okay, that's about the metal ion half cells. Now see the redox half cells. I told you in a redox reaction, what is taking place? There will be an oxidation half cell and a reduction half cell, right? So this redox reaction, we have learned in the redox reaction, it will have oxidation and reduction reactions. So that overall reaction we will be representing with the redox. The overall reaction we will be adding on the two half cell reaction, then we will get the overall reaction, right? So here I can take we can take the same example for the galvanic cell, in which the zinc is converting into Zn2 plus plus 2 electron, and thus zinc is losing the electron. That means their oxidation occur at where? At anode, right? And the Cu2 plus ion is gaining 2 electrons and converting into solid copper. Their gaining of electrons means it is reduction, right? Gaining of electron is reduction, and reduction occur at the cathode, right? So this is the oxidation half cell. This is the oxidation half cell and this is the reduction half cell. Now let's see how we can represent the overall reaction. While writing the overall reaction, the 2 electrons on the right side and the left side will be getting cancelled. And how we can represent this overall reaction? This overall reaction I can represent on the left hand side, zinc plus Cu2 plus ions converting into Zn2 plus plus Cu. That is what the overall reaction. So in this overall reaction, there it has two parts. There is the oxidation half cell and the reduction half cell. That is what we called the redox half cells. Okay? Okay. Now see the last topic of this chapter, that is you have to represent the cell from the given reactions. Okay, see here the first question is hydrogen plus chlorine gas giving 2H plus ions and 2Cl minus ions. See here this hydrogen gas is changing into hydrogen ions, H plus ions, right? That means it is losing electron. Losing electron means it is getting oxidized, right? The oxidation occur. Where the oxidation will occur? At anode, isn't it? And for this Cl2, chlorine gas is converting to Cl minus ion. It is gaining electron, right? It is having an excess negative charge. That means it has extra electrons. Gaining of electrons. That means gaining of electron is reduction. Where the reduction will occur? At cathode, isn't it? So how we can represent? We get the cathode and anode. Now we can easily represent the reaction cell, right? That means how we will represent. First we will draw the salt bridge, and on the left hand side we have to mention the anode. At anode, what is the ion forming? H plus ions, right? The H plus ions is in the aqueous solution. The H plus ions. Then the phase transition. The next one is the gas. Gas is hydrogen gas is there, and there is no electrode mentioned. So we can give the any inert electrode like a platinum, solid one. So your left hand side, that is the anode side, is clear. Now on the right hand side, that is for the cathode part. So at cathode, what is taking place? The chlorine gas is converting into Cl minus ions, right? So first we have to mention the ion, Cl minus ions is. Then phase transition to phase change, not phase transition, the phase change to gas, Cl2 gas. Then on the left side and the last corner, we have to mention solid. That's not solid is given here, so we can give any inert electrode like platinum. So this is the notation or the representation of the cell for this reaction, redox reaction. Now go for the next one. Here the zinc is converting into Zn2 plus. That means zinc is losing electron. Losing of electron is oxidation. So this is the anode, and it is H plus ion is converting to H2. That means gain of electron. So reduction occur, and this is the cathode. Now we can easily represent this one, right? So how we will represent? Because we have to draw the salt bridge. The anode on this side, anode Zn2 plus ion, Zn2 plus ions in the aqueous form, and the phase change to solid state is there, right? So it will be Zn. And what about the right hand side? The cathode, the H plus ions is in the aqueous form. The H plus ions, the ions first, then the phase changes to hydrogen gas, right? H2 gas. Okay. So here we can give the solid any inert solid substance, right? So this is the cell representation. Okay, I hope this electrochemical cell, that two electrolytic cell and the galvanic cell and the cell representation is clear for you. I will be coming with the second part of this electrochemistry chapter soon, and please stay tuned with Goscore for the next live session by your Nandini ma'am on the coming Tuesday. Okay, thank you all.